A FHIR Paradigm Shift. Deliver a secure FHIR platform in weeks with BDR. We automate the delivery of healthcare requirements by maintaining FHIR's expected ongoing resource changes. BDR's FHIR app will deliver a complete solution in weeks, not years, using our Spark 3.5, Java and AngularJS WildFly GUI solution. Our app immediately securely stores the FHIR data, encrypted, provides a GUI to access the data, present unencrypted data to an authorized requester, allows patients to view or download their FHIR data securely and encrypted with an accompanying, secured decryption module. Add BDR's 5-factor authentication using Google's open-source app, ICE 256 encryption of FHIR's data, and encryption of BDR's class code to prevent hackers from re-engineering our code to discover paths and locations of sensitive, secure information. Here the user logs in with a standard application user ID and password. If successful, the user is then requested and required to obtain a code from our version of Google's authentication application. Here we purposely enter an invalid code to show the user was blocked from entering the application. Now, after obtaining a valid code and entering it, the user is allowed into the BDR FHIR application. Here we enter the BDR FHIR resource administration and see existing FHIR resources and field elements and metadata. We now selected the Add Resource icon and are presented with a dialog box to add a new resource, for later use by users and patients. We are now adding the name of the new resource, metadata pertaining to this resource. Next, we select the new resource and now start adding one or as many resource fields and the field's metadata as needed or desired for the purposes of this FHIR profile. Now we establish a secure connection to a FHIR data source. We enter the necessary information to narrow down to the precise single patient we desire to report on, as patients may only see their own PHI information. If the search is done by a healthcare facility, they may have rights to see more and select one or more patients at a time, as well as authorized data scientists and analysts. Next, the user will click on their identifier or key and may begin to select the resources and the data values within each FHIR resource. After the user selects all their desired data fields they want for their viewing, reporting and ultimately, though optionally for the user's or patient's download, the available resources and values and sub-values within FHIR will be near ever-changing, and BDR allows for the updating of its application to match what is available from FHIR at the current time of processing. Here we can see the 4th and 5th factor or levels of security. We are viewing the double encrypted master keys, user credentials. Next, we are viewing how the PHI and PII data within the resources and the resource data fields that the PHI and PII are all securely encrypted. Without the ability to reverse engineer the Java class code, making one's way to the actual, usable decryption keys is near impossible. As I drill deeply into the BDR code down to the Java class libraries to view the class code that is usually in most applications easily viewable and able to be reverse engineered, here we see that the BDR class code is encrypted to protect against reverse engineering, removing the ability of hackers the advantage to find a company's secrets and paths to sensitive information through reverse engineering of the code. Now the patient or user selects to download the FHIR data they have authority to access. First, the user or patient is prompted to enter a password to enter the downloaded zip file, and next prompted to enter the password that will invoke a decryption application downloaded in the zip file that will decrypt the secure, encrypted downloaded data while in motion to the patient's or user's device. Now the user or patient has copied to move the zip file to an area to work with it. As the user or patient selects to open the zip file, they are prompted for the zip password to open the zip, and here we are viewing the download PHI data and we can see that the personal data is protected with AES 256 encryption. Now the patient or user wants to see their data request. In order to do so, they must run the decrypt application and enter the valid password in order for the application to decrypt the encrypted file that was downloaded that we looked at just a moment ago. After successfully entering the password, a new file is created that is readable by the patient and or user. This is why we call the BDR FHIR process an end-to-end encryption, 5-factor secure process for FHIR, CCPA, GDPR or most any data privacy regulation. And as we take a quick look back at the FHIR data source, we see all the data is still encrypted as we encrypted it upon its being loaded, encryption in motion, or even when it was at rest. Add BDR's 5-factor authentication using Google's open-source app, AES 256 encryption of FHIR's data, and encryption of BDR's class code to prevent hackers from re-engineering our code to discover paths and locations of sensitive, secure information. This same 5-factor security protects for CCPA, GDPR, GRC and most every data regulatory requirement. Reach, BDR at 847-44